Hi, welcome to Smart Guns, building a modular weapon system using behavior trees. I'm Ramon Vilalmat, and I'm a gameplay programmer at Ubisoft. I've been working in video games for more than 10 years now in different companies. Just to get a little bit of background on me before starting, I worked at Reactable, Novorama, Crytek, and Ubisoft, and worked on several kinds of different games. Today we're not going to talk about Ubisoft game in particular, but we're going to talk about how we build the weapon system for hand while I was working at Crytek, and how some of those techniques actually carried over on other productions along my career, like Ubisoft game I'm working now. And before actually starting talking about the weapon stuff, I would like to give a little bit of context on where that system actually lives. And this lives on the game called Hand Showdown. So how does this game works? Let's just get in a nutshell. Hand is a PvP, PvE game where there are enemies in the world, which are called bounties, enemies that you need to kill, grab its bounty and reward and actually extract it. This is done by teams, so you're not playing alone. You are between teams 2 or 3, and you play against other teams to actually get the bounty first in a kind of semi-battle royale kind of genre. We wanted the game to be super slow-paced, so it's become very tactical, and that put a lot of emphasis in all the weapons and equipment that the actual players are using. This allowed us to actually be able to rebuild all the weapon system that we inherited from Crysis games and stuff like that, so we could build it from scratch. And this was a big opportunity to actually do things differently, and that's what we actually did, and I would like to actually show and walk through you guys around this process. So let's go for the weapon stuff. So what is a weapon? A weapon in hand is divided into 3 different components. First one, I would say it's a presence component. This actually contains all the information that binds the weapon to the wall, so how it looks, how it sounds, and all those kind of stuff, visual effects, audio, lights, all these sort of things. This is how it looks, all the configurations on how this thing is actually represented in our virtual world. Then we also have the stats. The stats would be kind of the internal state of the weapon. It's just a state snapshot of what we currently have there, meaning ammunitions and other kind of variables and states that our weapon has at the moment. And finally, we have one logic component, which is the one actually updating those stats and the presence to actually reflect what's happening. This will be kind of the brains of the weapon. So, of these brains, let's focus on the actual logic because what we're interested in here. The logic is based on actions, and those actions are kind of atomic elements that perform stuff into the weapon. As an example, we can have fire single, will be single shots. Fire charge will be like charging a shot and then releasing on button up. Fire rapid will be more like a machine gun, or having a reload loop, which reloads one bullet at a time. Reload clip will reload the clip, melee actions, you name it. All these actions have events, and they work with events, saying like start, which we'll call trigger, release, which will be like a stop, a cancel, some interruptions, because some actions can happen at the same time, or even custom events if we need to do things like, I don't know, scope changing zooms or things like that. We can have any events that we want, and then those atomic actions will react. So basically how this works is we have some slots, and we receive actions from the outside with their own events, and we can actually select for each weapon what of those atomic actions are we gonna perform. So let's start building some examples with that. First weapon would be a super simple one. We have 2 actions, action reload and action fire, and we assign a fire single and a reload loop into that weapon. So this will look like this. On this weapon example videos, we'll see that the actual actions that are active and running will be highlighted in green, and we have this little dot at the left side, which will just also be highlighted when we receive the event of trigger for that action. Here we can see regular, fire single, and reloading in a loop. But of course, as I said, those are sockets. We can actually change those sockets and build completely different weapons just by using those atomic actions. Here we can actually build something more like a machine gun. It will still be a gun, but it will be like a pistol, but it will be like a fire rapid, and it will reload the whole weapon at once. As we can see here, we can actually shoot super fast with a single trigger, and we will reload the whole gun in one go. So let's do more. What if we can actually put this fire rapid and reload loop at the same time. The thing is that nothing prevents us to actually trigger both actions at the same time. And we can end in these situations where we have glitches. I guess that's not intended in our case, where you can actually be firing and reloading at the same time and get an infinite ammo glitch, right? So at this point, it's like, yes, okay, this is cool, it's atomic, it works, it's granular, but we need to add something else. So in order to fix that, what we added is a dispatcher on top of it, which will handle all the actions that the weapon receives. And then we'll decide what needs to be interrupted, what are the transitions, if we need to save that action for a little bit later. For example, if I'm actually moving from reload to fire because the weapon is not aiming to anything, maybe we need to buffer that shot until the transition finishes and do the shot. So we can actually handle all those sort of edge cases and have a good feel on how the weapon should behave and what is allowed and what is not allowed. Here in this video, we can actually see how the dispatcher will interrupt our reload to actually perform the fire when those actions are happening at the same time. Okay, those are sockets. The thing is that the sockets are not named. We don't need to have fire actions on a fire action and melees on a melee or aimings on aimings. We can actually socket anything to anything. So basically using the same interface that we had before with the fire and reload or fire and melee, we can actually put both in melee. And this way we can actually simulate even swords and things like that, just having a single action that performs that melee logic. Okay, but that sword looked quite not great. The thing is that most of the time you don't want to have only active actions. You want to have also things that run in the background doing some logic stuff, maybe changing the state over time, or changing materials, changing lights, adding particles, changing the audio, whatever crazy things that you might want to do. That's why we added passive actions. Those actions don't require any triggers or any events. They just work in the background, they do stuff. In this case, we want to do the same same scenario. We have our fire that will do the melee. We have our melee that will do the just regular melee. This way we can have light and heavy attacks. And then we will change our material with the passive actions. We will add some glow, some lights, a lot of stuff. And here we have our result. So we have 2 melee actions, and then our material is changed by these passive actions. This is just a dummy example, but reflects how the basic architecture is laid out. Okay, this is our tool set so far. So let's go and build something nicer than just some simple examples. Designer comes and say, okay, we want to use the melee and fire with the same button, because usually button layouts in games, it's a fight with designers on who owns which button to do which. So we want to just merge melee and shooting on the same button. And we will do one or the other based on if we're aiming or not. So solution number one would be to just create that action, right? One that does the fire and melee depending on something. That will be just on a new atomic node that will perform as the other ones, and we can socket on those places. But the thing is that we already coded fire single and we already coded melee. It would be super nice if we can have something that we can actually bundle those things, and we'll do the selection and execute one or the other. The thing is that those sort of problems has been solved over and over again. And I was looking, it's like, wait a second. If we have something like a condition, and that condition node will actually execute some child nodes based on that condition, that would be great. I just need to build a super simple node with an if statement, and we're good to go. The thing is that this resembles something that already exists, right? So I went to the guys like, okay, why we don't borrow behavior trees and all its power to actually do this sort of things? So basically, let's go and input, instead of an action node, a behavior tree node. So we can actually use all this power to do our logic in a way granular way, so that the designers don't need code to actually do their stuff. So for this, let's say, what do we have on the behavior tree family as the most basic stuff? Let's cyber the selector. Selector is exactly what we need here. Selector will grab a condition and do the false node or the true node based on that condition. That works perfectly fine for us. So let's build it. We have an action with the aiming, which will enter in aiming position or not. And then we have an action for fire with that selector saying, if I'm aiming, I'm going to do the fire. If I'm not aiming, I'm going to do the melee. Here we can see it in action. So we can see not aiming, melee, that worked fine. The thing is that now, okay, now that we already have this infrastructure to have trees in there, what else can we do? Let's add decorators. What's a decorator? Okay, we have a decorator, which is a node that will decorate the effect of the of its child node. Perfect example would be a cooldown. Cooldown, super simple node, just check the timer each time that it's triggered and will not allow anything to pass through if that criteria is not met. So here we have it. Just fire that triggered and will not allow anything to pass through if that criteria is not met. So here we have it. Just fire that's... What else we can do with that? Debug text. We can actually have some debug text to actually know when things happen. This is just to illustrate the example, but what we'll do is the same thing that we did before for our feature, but with some debug text so we can actually visualize better what's going on. So each time that we fire, we see the firing. Each time that we do the melee, we're going to see the melee. We can also do sequences. Sequences will be, as everybody expects here, it will start executing all the actions one after the other. So we can have as many childs as we want, and we'll do once action A is finished, it will start action B, and then it will start action C, and so on. For our example, we'll have this sort of pistol with 3 cannons with the actual colors, red, blue, and green, and we're going to execute those in sequence with some delays in between. So basically, each time that we press the fire, only once, it will do the whole sequence. Firing, waiting, firing the next cannon, and each one will have its own properties, its own bullets, its own fire configuration. What else do we have? Parallels. Parallels is also super powerful. This will allow, opposite the sequence, it will execute all its childs at the same time. We'll have the same example, but in this case, we'll shoot the 3 cannons at the same time, or the 3 colors with everything single shot. So each time that we shot, we can see that the actual 3 different colors are shot at the same time. Cool. Now we have trees. What can we do with this? Let's do some cooler features with only our atomic nodes. So the designer comes and wants to build something like what we call like a broken weapon mechanic. So basically, when we run out of ammo, we'll have to fix that weapon before being able to use it again. And this fix will happen while reloading. So what we want to encourage is people to reload before running out of ammo. So we have this extra punishment when that thing happens. In order to do that, let's see how those trees will look. We'll have an action for aiming, which will do the aim. We'll have an action for fire, which will have the same thing as before because we want to mix those melee and fire into the same action. And we have the reload. Here is where the new stuff comes in. So basically here what we'll do is each time that we reload, we'll do a sequence of do we need to fix the weapon and then doing the reload. In this do we need to fix the weapon, we need to check is the weapon broken, meaning is the ammunition positive or it's 0. Based on that, we will play a reload clip which will change internal state and play an animation, or we do nothing. Just for the interest of the presentations, I added a passive action too. Also with the selector, passive actions can also run with selectors and also their own trees, which will change the material so we can see when the weapon is out of ammo and in that broken state, and when it's perfectly active and working. So here we can actually do an example. We can actually shoot. We're not running out of ammo, so the reload is completely standard. And now that the weapon is broken, we need to actually do the fixing and then start reloading. Okay. Weapons usually, for everybody in video games, also have this component of modifications and putting the scopes and silencers. Those kind of things are super cool, and we could not opt out of it. We wanted to have our weapons a lot of charisma and character, and we need to have something working with attachments and modifiers. It was a big part of the Crysis games, and we wanted to keep this thing for our game, even if it was not super player facing, but we wanted to have this variation even on the depth part of it. So basically what an attachment is. This attachment will be an extra thing that we can put in the weapons, just as an option of what we can actually attach to it. But as a weapon, it has 3 different components. First one will be the presence, same thing. This is how it looks, how it sounds. Maybe the silencer will have to modify its audio triggers and stuff like that, so that it changes the sound of the weapon. Maybe we need to put some sort of physical mesh and changes. Maybe we need to change how it animates because it's handled differently. This will be on the presence one. Then also we have one stat. That stat will be just going to the stat of the weapon and saying this attachment is present now, it's active. But there will be no logic associated to that thing because the weapon will decide how we use that attachment using the trees. So basically the behavior trees will be the ones defining how the logic of that attachment is happening for that particular weapon. So let's build two examples with this. We're going to build a weapon that has a potential sniper scope and a potential multi-fire barrel, like the one that we've seen before, the one with the colors. So let's build the first action. The first action will be the aim one. We'll have a selector on the aiming, because depending on if we have the sniper scope or not, we want to do one aiming or a different kind of aiming, one with more zoom and more precision. We can see that the thing is duplicated for values, but we will come to this later. And then we'll have an action for fire, which is the same thing. We will select which kind of barrel do we have, and then we will have different kinds of firing. One with it will be the regular firing, and the other one will be the parallel shooting the three cannons at the same time. So let's see this in action. This will be the regular gun, as it is, but we can actually change it to have a sniper scope, and we change the parameters. Now we're having all this functionality with different values. And same thing for the multi-barrel stuff. Okay, let's build something different. Now let's build a feature. Designer came and say, I want a feature based on gun spins. Gun spins are cool. But what I wanted to do is that for each gun spin that we do, we increase our precision. And then when we shoot, our precision goes back to the regular one. So how would we build this with our current code and setup? So basically we'll have an action, which we'll call gun spin. Maybe we have a button to actually trigger that, which will play an animation and do the gun spin and modify a stat. Usually those are reload clips. It's the same thing, one single animation that changes the stat. And then we'll do an action fire, which depending on how many gun spins do we have, will execute a different kind of fire with more precision or less precision. We can already see that this does not scale really well. Those fire singles have just for one different value on spread, because this is the only thing that we're changing. We need to duplicate all those nodes around. So how did we circumvent that? Because 3 gun spins is fine, but what if we want to do more than 3, like 20? The granularity, it just explodes, right? The trees will grow really wild. We'll have a lot of duplication in there. So how can we fix this? Okay, in order to do that, what we came across was this idea of expressions. For expressions, it's this thing that, for example, if you have something like spread, in our case, it can be equal to 10. That's what we have so far. But what if we can actually put formulas in there? So we can actually give these little twists, because designers don't want the thing exactly how they are out of the box. They always want this little twist that makes the gameplay slightly nicer and cool. So if we can put those formulas in there for the values, it will be gold. So what if we can do things like spread is based on the ammunition left that I have, or maybe want to check something like progression or metadata. The owner of the weapon has an upgrade that bought and want to be more precise, or maybe for our case, we want to just do an interpolation based on spins. This was super cool and actually reminds on how we use those formulas in Excel or programs like Adobe After Effects, where you can actually get that extra power from any field by putting a formula in there. That was super, super powerful. And we can actually see here in actions where we can grab any field from any action and just promote it to a formula and put any formula that we want based on stats, owners, whatever you expose in there. The power was there. The only problem that this had is that it was super powerful, but not that great and not super used because of 3 main reasons. First one is the scary. It's text, it's code. Most of the designers need training in order to do those things, and typing stuff and formulas is not the most friendly way to actually approach non-technical people to deal with this sort of stuff. Also, because it's text, it's contextless. So this means that discoverability is really low. I need to plot documentations. Basically, if I need to type a new formula, I don't know what is available to me. I don't know what formulas I can use. I don't know how to format them, how to do branches, conditions, all this sort of stuff. And at the end, it's also error prone. You can actually mismatch parentheses. You can input stuff that is not valid in the first place. So in order to actually fix all those things, this was on the back of my mind for a long period of time, we shipped hand with actually those sentences, having the type version. But when I joined Ubisoft, I had the opportunity to rethink some of those models, right? So what I think is like, okay, how can I achieve the same sort of power, the same sort of approach for adding context to values and adding formulas so they depend on the context, and the value depends on the context, but in a way that we fix what I just mentioned. So the best way to do that I could come across is going back to the human nature on shape matching and how kids learn to code, right? Let's go to the basics. And I managed to get this sort of idea of adding functions in a node basis, but instead of graphs, doing it like in a stack and socket, stacking things and putting it in sockets based on shapes. This allowed me to have something strongly typed. I also can discover all the nodes that are available. I can add descriptions. I can help anybody that is building the content with useful tips and descriptions. It gets compact. It's not those graphs that take the whole screen. Things get compact because they stack one inside the other. And it's also contextual because of that. I see one socket, I know what I can actually put in there. I know all my options. This will be the example that we're doing for the weapons on this new system, which is more visual and more appealing. Here we can actually even build local variables and then deal with them. Also, because the thing looks more like a scripting language, more than just a formula, we can actually even add more multi-line options there. Things like checking for crouching so that we can get more precision where crouching. We can even factor in that on the weapon spread. So we have that chunk of logic completely data-driven on the spread itself, not in the actions, not anywhere else. So we managed to extract that same. This gladly started as something for the metagaming on Watch Dogs Legion, and it became the backbone as a scripting system for most of the game. It's used on missions, it's used on UI, it's used on progression, it's used on gameplay, it's used all over the place. Okay, now we have the weapons. We can build weapons, we have the trees, we can customize how things interact, sequences, how things happen at the same time, how those values actually link between each other, how we can add context to the values. But there's one thing missing. We want to build weapons, and we want to build weapons fast, and we want to iterate fast on those. So what do we want to do with this? We wanted to do something that we can actually find those values that we want to put in there, because at the end it's all about tweaking those values for the final stages of the project. And we want to find those magic numbers fast. And we want to have something that uses reflection and serialization systems that are already in place. We don't want to build anything really super new on top and something for people to learn. So we had this sort of thought process, and we thought, who are the people that are tweaking values real time more effectively nowadays? And basically, I think that music industry is doing a really good job at that. They can do a lot of like values and floating number tweakings on the fly at the same time. So if they have been doing this for years, let's just borrow that technology from them. So what we did is just enable MIDI interface to the serialization system for our game, so we can actually change any value exposed to the editor from a MIDI protocol. So we can actually real-time change anything without having to forget how it felt before, quitting the editor, relaunching, changing numbers with the keyboard. It's just plug and play. You change it on the fly so we can actually get the feel and magic faster. Here we can see on this video how we can actually change even animation IKs. Anything exposed was available. After doing that, we actually realized that this sort of tech was really, really interesting for building VR games. Because in VR you actually have a headset, and the headset you are basically blindfolded. You're a completely different world. Then when you want to tweak stuff, you will need to get on and off your headset, change things, put it on. It's kind of going back and forth. That virtual wall is not great. The thing about the tangible interface is that I know where my knobs are. I can touch them while not seeing it and change the things while I'm actually in that virtual wall, which proved to actually speed up a lot our tweaking steps while building VR experiences. Last but not least, when dealing with this sort of MIDI controllers, it's really important to get the values that you're sending to the game back to your hardware, just to not lose the sync between what I have in the physical wall with what is in the virtual wall. Basically, this means that if I'm tweaking weapon A and I have it perfect, and then I move to weapon B, that's what I have on my physical wall will not match what that weapon values represent. So it's super important to be able to actually remap those things so that we never lost context of what I'm actually changing. This can be done even for Boolean things like LEDs and buttons and things like that, so we can actually see if our cheat commands are enabled or not. It's really actually useful. You can just watch at your hardware and you can visualize how the weapon will feel, or how whatever you're tweaking will feel into the game straight away. So basically, with all this, we managed to, with just some atomic actions, be able to build lots of stuff for our game. So the designers went wild and were able to build pistols, shotguns, sniper rifles, melee weapons, crossbows, super exotic weapons like the bomb lance, consumables, which are not weapons directly, but kind of feel the same way logic-wise. So the system was a good fit for this kind of things. Throwables, more throwables, but more complex, even placing traps. So all the equipment was the thing. Powers, dark powers. Basically, most of the game that you're playing, most of the 3Cs are using the weapon system. So to summarize everything, I hope you enjoyed this content. And to summarize, I would say that when you have a problem and you want to tackle it and try to solve it, I would say explore outside the usual box. Sometimes other industries have solved your issue 1,000 times. They have better solutions than what you can come up with. And they already refined them. So just piggyback on all that expertise and knowledge and wisdom that comes from other industries, other fields, stuff like that. Also export. As an AI community, we have really good tools and we're using them for AI that just goes in the cover and shoots, and it can be used for other things. And this is a perfect example. Actually use something like behavior trees, mainly used for AI behavior and reasoning to actually build weapons, which is on a different section usually in games. And at the end of the day, I would say empower your content creators. Try to make your systems so that they can build stuff on their own. So we can remove bottlenecks and they can build stuff fast so that we can actually work at the same time empowering ourselves. I hope you liked it. This was Smart Guns, and yeah, any questions, feel free to contact me. Thank you.